Hi everyone, this is HD Sharma. I am a master's student at BITS Pilani. I am doing my Masters of Engineering in Computer Science department here. As a part of course curriculum, we were given a project which is to make blockchain-based platform for online transaction. So I, along with my teammate Kashyap, made a project for KYC verification using blockchain. So I have told you enough about me. So now let me introduce you with the project, like what is the need for blockchain in KYC verification and also the setup details about the project. We all are aware that in traditional KYC system, each bank will conduct its identity check. Each user is checked individually by an individual organization or government structure. Hence, there is a waste of time for checking each identity from scratch. The blockchain architecture and the DLT allow us to collect information from various service providers into one cryptographically secure and unchanging database that does not need a third party to verify the authenticity of the knowledge. It makes it possible to form a system where the user will only need to undergo the KYC procedure once to verify his or her identity. Talking about the technologies used for frontend, we have used ReactJS. For backend, we have used Ganache as an Ethereum development network. We have also used Web3.js and Truffle. The wallet used here is Metamask. I know you might not be familiar with these terms currently, but I'll be explaining them shortly in the video, so please watch the video till the end. The main language used in Ethereum is Solidity, which is why we have also used Solidity as our main language for creating smart contracts. Smart contracts are simply programs stored on blockchain that run when predetermined conditions are met. They typically are used to automate the execution of an agreement so that all participants can be immediately certain of the outcome without any intermediaries' involvement or time loss. Okay, so I have talked about Ganache very frequently in the video. So now let me quickly tell you about what Ganache is. Okay, so Ganache is a personal blockchain for rapid Ethereum and Corda distributed application development. You can use Ganache across the entire development cycle, enabling you to develop, deploy, and test your decentralized applications in safe and deterministic environment. Ganache comes in two flavors. We can use the UI version also, and we have the CLI. We have the option of CLI also. For our project, we have used the UI of the UI application of Ganache. Okay. Okay, so if we talk about now MetaMask, MetaMask, as I told you, that MetaMask is a cryptocurrency wallet which is used to show the transactions happening while a blockchain application is running. We can add MetaMask as an extension to Chrome. For setup, we need to connect MetaMask with Ganache because this is how we can show you exactly what kind of transactions are happening while a user is trying to verify itself from an organization like bank or any other government entity. Okay, so this is the article we have used to know how to connect Ganache with MetaMask. You can get all the information from that article. And okay, so now let me tell you about how we have connected the Ganache UI application with the MetaMask wallet, which we have added as an extension to the Chrome. Okay, so let me open the Ganache application first. Okay, so this is the Ganache application which you guys are looking at right now. Okay, so this is the UI of the Ganache application where we have accounts, we have blocks, the transactions, contracts, events, and logs. Okay, so for connecting Ganache with MetaMask, we need only these two entities. Okay, so we will be creating a network, a different network in MetaMask, which I'll show you later. On that, we have to fill the network ID and the RPC server's URL, and that is how we can connect MetaMask with Ganache to local environment. Okay, so if you can see this, here we have some fake addresses at the 100 Ethereum as a balance for every user. So these are kind of a fake. These are fake entities. because we cannot go and buy Ethereum just for testing and deploying purposes. That's why we are using this environment. Okay, so now I'll tell you about how to connect MetaMask with Ganache. So this is the MetaMask UI interface in which I have already ended up network as Ganache because we have connected. I have already connected the MetaMask and Ganache. Okay, so here we can import accounts from the Ganache local environment. Let me show you how. Okay, so here we can import an account just like that. We will go here and we will copy its private key. Okay, so now we will just paste here the private key of that account and we will import it. And as you can see, we have connected Ganas. That's why we are having 100 Ether as a balance. This is how we can add and import more accounts from Ganache environment to the MetaMask wallet, and each entity will be having 100 Ether as the initial balance. And as soon as the transaction goes on, the user comes and verifies itself, and everything happens in the project. These transaction will be happening automatically because currently I'm doing it manually just to show you how this works. Okay, so it was all about MetaMask and Ganache and how they are useful in our project. Now my teammate Kashyap will show you the demo of the project and also the logic flow of the application.
Let's start with the logical flow of application. As we can see from the flow diagram, it's pretty simple to understand. So first we need to create a bank entity and link it with a cryptocurrency wallet. So for every transaction in the application, we have to pay some gas fees in terms of Ether. So what exactly are the gas fees? So in layman terms, we can say that a gas fee is a blockchain transaction fees paid to the network validators in the exchange of their blockchain services. So basically, this is an incentive for anyone to stake their ethers and contribute to the network security. So similarly, we can create customer entity and provide the details, and also customer entity needs to connect with their cryptocurrency wallet. So customer entity can send their details to bank for KYC verification. Once the request is received, so bank can verify whether the customer details are correct or not, and based on that they can accept or reject the KYC request. And customer can also update their KYC information and send to the bank for re-verification. So now look into the smart contract of our projects which we have deployed. So basically, what is the smart contracts? So smart contracts are the computer programs, or we can say protocols for the automated transaction that are stored on blockchain and run to meeting certain conditions. A smart contract works in the same way as a traditional contract. Smart contracts are just a program that execute exactly as they are set, just like traditional, just we can say that just like traditional contract, which is enforceable by law, smart contracts are enforceable by the code. And we have written our smart contracts in Solidity language, which is an object-oriented programming language mostly used for implementing smart contracts on various blockchain platforms, mostly in Ethereum. Get to the demo part. First, we will open Ganache. Ganache is basically Ganache provides the demo account with Ether, so we can use for development purpose. Click on Quick Start. Okay, yeah. So we are getting demo accounts with 100 ethers each. This is the RPC server with the link, and here is the gas limit. Now let's get to the MetaMask setup. We will add extension of MetaMask in Chrome. We will create a new wallet, set a password. Okay, click on I have read agree. Next, remind me later. Okay, so we have set up the MetaMask. Now we will change network to Ganache. Ganache, enter RPC URL. We'll copy URL from here. Uh, Paste. The default chain ID will be 1337 and the currency symbol will be ETH because we are using Ethereum for development. Okay, so my account is created. Now we'll import the yeah, we can also see the MetaMask extension in Chrome. Okay, we will import our account in MetaMask. So for importing, copy the private key of any account, go to MetaMask extension. Okay, import account, paste your private key here and press import. Now you will able to see 100 it's on your account. Okay, now let's start the application. For that, go to CMD, write npm start to start the front end part of application. Okay, it is starting the development server on port 3000. Okay, you have to connect to your account. So I have selected account 2 as my primary account. Click on next, connect. Okay, so this is how the basic UI of our project looks like. This is the address of the current wallet which are connected to, and there are no verified bank account in the network. So first we'll create a bank entity. So I am creating bank entity. Click on create bank. So here are the estimated gas fee which we have to pay in ethers. So I am confirming the transaction. Okay, the you are now a verified bank entity. Now we'll go to bank entity to verify the request. So here is a bank entity. Now I will go to view organization internal access and select on view user request. So now I'm able to see the KYC request with the name of Kashyap. So first I will verify the data whether data is correct or not. So I will copy paste this address as customer's wallet address. Now I will enter the Aadhaar card number, PAN number and click on verify. So it is showing as verification as successful. So customer is legit. So now I can accept the KYC request as a bank entity for the customer Kashyap. So now clicking on accept request, I have to pay some transaction fee. I will click on confirm and the status change. Now I will go to customer entity and check whether my request is accepted or not. So for that I'll go to existing customer and check my status. So my status is showing as accepted. If as a customer entity I want to change my data, so suppose I want to change my Aadhaar card number, so I can change it from here, entering PAN address, and also if I want to verify with another organization address, also I can do that. But currently I will verify my KYC to the same organization address. So change data. Again, I have to pay some transaction fees. Clicking on confirm data change. Now I'll again go to bank entity, view organization internal access, click on view user request, again able to see the request. Now I intentionally entered the wrong Aadhaar number and check. Okay, so it is showing verification as fail because I intentionally put the wrong Aadhaar. Now I will reject the request. Copy paste the address and click on reject request. Estimated gas fee, click on confirm, status change. Now we'll check on the customer entity, what's the status. So the current customer status is rejected, as we can see in the status. Now I'll again open one more client to demonstrate one more scenario. So starting the development server. I am selecting account number 4. Next, connect. Sorry. Yeah. So the connection has been established on this address. So I will create a new customer, entering the Aadhaar and PAN details and copy pasting the organization address. I have to pay some transaction fees. Okay, you have successfully made an account. Now I'm going to existing customer scenario and verify what's the status is. So currently I'm able to see the customer status is showing as a pending because the bank has not yet processed the request. That's why it is showing pending. Okay, so that concludes our project demo. In future work, we will try to improve the project's user interface and also try to add many more banking related features to it because there are many ways that using blockchain we can change the traditional banking. We can use blockchain in things like payments, settlement systems, trade finance, also giving loans, credit, managing securities, etc. So with the help of the decentralized payment ledger, blockchain can make payments faster and charge less than the current bank do. Blockchain can also affect clearance and settlement system where distributor ledgers can reduce the cost of operation and bring more real-time transaction between the financial institution. Okay, thank you.